Hey guys, first video in a while. Don't forget about Francis, our creepy decapitated unicorn. I'm so weird. Anyway, area of parallelograms and triangles. This is 10.1. And let's get started. The first thing that we want to talk about are the properties of parallelograms, right? So there's a couple here, so nothing too crazy, but some writing. The first one is that opposite sides are congruent. Okay, so if we have a parallelogram, let me see if I can move this over. All right. All right. If we have a parallelogram, let's say this is our parallelogram. These opposite sides are congruent. This opposite side and this opposite side congruent. Right? Also, the opposite angles are congruent. This should be a little bit of a review from earlier this year. And then their consecutive angles are supplementary. That means these two angles, if you add them together, would add up to 180. And these two angles, if you add them together, would add up to 180. Supplementary angles, consecutive angles are supplementary. Then we have the diagonals, okay? They bisect each other. So right here where they cross, that means this piece would be congruent to this piece. And this piece right here would be congruent to this piece. So properties of a parallelogram. And then we're going to start talking about area. All right, area of a rectangle. Just giving you guys a second to get it all copied down. Trying to not go so fast. Really appreciate your feedback. All right, so here I have a rectangle, okay, in this wonderful little box. This would be the height, and this would be the base. And to find the area, you multiply the base times the height. All right, area of a rectangle. So let's look at it when we have a shape that looks like this. All right. And if you notice, originally it was 3 separate shapes, and I divided it up into 3 separate figures, one that I highlighted in green, one that I highlighted in pink, and one that I highlighted in orange. The reason I did that is because I want to find the area for this entire figure. All right, so what I do is I find the area for this green one by taking the height times the base, which would be 3. So 3 times 14, and I'd get 42, right? And then I take this second figure, and I multiply the base times the height, which would be 6 times 3, and I get 18. Then I take this last figure, the orange figure, and take the base times the height, multiply them, and get 30. And I add them all together, and then I get the total area is 90 units squared. So breaking apart your shapes is super important, right? If you look at some figures, you won't know what to do. So if you break it apart and find the area of the smaller figures that make it up and add them together, you could probably find the area. So my hint to you, my hint in red, cut the figures into shapes of objects with areas you know how to find, and add all the parts to find the total area. So cutting it up. All right, I'll go ahead and flip to the next page. And we want to talk about the area of a parallelogram. All right, the area of a parallelogram is similar to the rectangle, and it's the base times the height. But the height is a little different. The height has to be perpendicular to the base. So it's not this slanted side over here or over here. It drops from the top, forms a 90-degree angle, aka perpendicular, and then you multiply those two, area of a parallelogram. All right, so we would want to find the area of this parallelogram. And don't be fooled by this diagonal side that's listed here, 8. Remember, that's not the height. The height has to be perpendicular. So your area would be 10 times 6, and you would get 60 units squared. Okie doke. And then, if we're trying to find the area of this figure, this one gets a little bit more complex. And you thought we could forget special right triangles. Sadly, we cannot. All right, well, we have this parallelogram. And here we have this line that drops down the height. And we know that this is a 45-degree angle and that this is 90 degrees. So that means right there we have a special right triangle. 45, 45, 90. And I know this side, I know that side across from my 90, my n rad 2, and I know my sides across from my 45 are both n, right, based on the right triangle trig. So we're going to solve for n, and by solving for n, we should be able to figure out the height. We know the base already, that's given to us. So we're going to do across from our 90 here. And 8 equals n rad 2. I'm going to divide by rad 2 and divide by rad 2. I'll have 8 rad 2. N equals 8 over rad 2. Got to get rid of that radical on the bottom, so I multiply the top and the bottom by rad 2. I end up with 8 rad 2 over 2. I now need to simplify these two numbers outside of my radical, which is 4 rad 2. All right, so now I know that n equals 4 rad 2. Well, that's great because n is the height right here. So I would take 20, my base, times 4 rad 2, and I would get 80 rad 2 for the area of my figure. If you guys have questions on that one, be sure to ask. So now we're taking these right triangles a step further and finding their sides, but then using those sides to find the area. It's layered, okay? All right, next one would be area of a triangle. All right, so here's a couple triangles. And it's going to be the base times the height divided by 2. All right, the height must be perpendicular to the base. So right here would be our height going down 90 degrees, perpendicular. Well, this is a right triangle, so that one's easy. And then right here would be another height. We'd need to know what that was for this triangle. And then we could figure out the area. So let's do, well, we'll do some examples tomorrow in class on that one. All right, that's it for today. I hope you guys did good on your test, and I will see you, oh, look how I spelled area. I'll see you guys on Thursday and Friday. Bye.